Okay, so we survived question 1. We're now on to questions 2 and 3. In question 2, we're looking at how can an equation with an exponent equal 1? Well, there's a few different situations. Of course, we could have the power equal 0. The power could be 0. We could also have the base be 1. We could have the base equal minus 1. But we also have to have an even power in that situation because we want the result to be positive. So these are the possibilities here. Alright, so let's now do some calculation with this. So the power could be 0. So with that, we have to keep in mind that the base is not equal to 0. So we should keep in mind here that x minus 3 cannot be equal to 0. So x cannot be equal to 3. So we'll just keep that in mind over here. For our main calculation though, we're going to have 2x plus 5 equal to 0. So that's the power there. So 2x, if we solve this equation, equal to minus 5. X equal to minus 5 over 2. So we see that that's not equal to 3, so that's a valid solution. Right, so for the base equal to 1, the base is x minus 3. So this could be equal to 1. So if we add 3 to both sides, x could be 4. That's possible. Or we could have the base equal to minus 1. So let's try that. X minus 3 equal to minus 1. Adding 3 to both sides, we have x equal to 2. But we also have to check that if we have an even power here. So if x is 2, we'll substitute this into 2x minus 5. So we've got 2. Instead of x, we're going to substitute 2 plus 5. So let's see, what do we get here? We get 9. And this is not even. So because it's not even, this solution does not work. So we have 2 elements in our solution set. We have minus 5 over 2 and 4. Great, okay, so in question 3, we've got some different equations here. We were told that the values of x, y, and z are between 2 consecutive integers. So that can be interpreted slightly differently, but what it means is that x is between 2 integers, y is between 2 other integers, and likewise for z. So here we should look at the powers of 3. We have, 3, 9, 27, and that's all we need to go to, because we can see that 18 is between 9 and 27, which means that, of course, remembering that this is 3 squared and 3 cubed, so what that means is that x must be between 2 and 3. So those are the 2 consecutive integers for x. And we'll do the same thing for y and z. I want you to pause the video now and see if you can go ahead and do that. Alright, so hopefully you've had a try. So let's see how I went about this. I look at the powers of 2. So for the powers of 2, we can say, what we got? 2, 4, 8, 16, 32. Oh, that's bigger than 21, so we can stop there now. So we can say that 21 is between 16 and 32. When we think of that in terms of powers, that was the power of 5 for 32. So y, when we look at the exponent, must be between 4 and 5. And then look at the powers of 5. So powers of 5, we've got 5. 5 squared is 25. Oh, there we go. That's enough. So that's big enough already. So we can see that 10 is between 5 and 25. So when we think of the exponents, that's between 2 and 1 for z. Right, so that's the first part. We found the consecutive integers for x, y, and z. X, y, and z. Now we need to look at the question, see what we're asked to find. Find these consecutive integers. So we have done that, and write your results. So we'll use those results to write these in ascending order. So that means the smallest will be first. So which one of these must be smallest? Well, it has to be z. So we can say that z would be the smallest, and then the next smallest, x, That's between 2 and 3, and then y. Some of you might like to do it in inequality form. That's fine. Just make sure that the z is the first number. The smallest number must be first in ascending order. So either one of these two are fine. All right, great. So well done so far. We're going to now get our calculators out for question 4, and we'll see you in another video for that. Bye for now.